Men, and I use the term loosely. Hey, you're going to get a 2-for-1 video today. I'm going to do a little short segment on the follow-up for the three chucks video. And yeah, there's only two right here, but anyway, that's what it is. And then I'm going to talk about some cracked crankcases that I'm doing some repairs on for a customer. But anyway, to get us started, these are a couple of chucks. This is the one that was one of the subjects of last week's video. It's a Jacobs. This is a Jacobs chuck 2. This is what they call a super chuck, a ball bearing chuck. And these things can be very expensive, like $250 to $400 or $500, depending on where you get it from exactly, I guess. This one is probably a couple of $100. I didn't buy either of these new because I don't have that kind of money. eBay, and I don't know where this came from. This might have been on a machine that I bought. You could bet that if you buy a drill press or a mill or a lathe, it ain't going to come with the Jacobs chuck. It's going to come with made in China for $67 chuck. But anyway, just kind of for reference. And I mentioned in the video that the rebuild kits for these are available and they're very expensive. This one has stamped right on it, 16N service kit. The service kit for this one is about $210, $220. And, this is a more expensive chuck. This one, the number is not stamped on it. It's a little harder to find a number on the internet. But this one is also in the neighborhood of $200. So if you jack up your jaws on a quality chuck, replacing them isn't cheap. But anyway, just kind of FYI stuff. I got comments on that video. And, one of the reasons we're talking about price is the first comment. The first comment says, this isn't the first comment I received. It happens to be the first comment on the list. But anyway, Jim GS3JO says, if I'm ever in the chips, $, get an Albrecht chuck. He has one for 1/4 inch and under drills and it runs dead nuts on. Yeah, I bet it does. I have heard of Albrecht trucks, and I've heard that they are very high quality, and I heard they were very pricey. They're also keyless for the most part. They probably make keyed ones, but I think they're most known for making high-quality keyless trucks. Anyway, I priced those out because I saw this, and yeah, $700 to $1,000. Wow. There are, of course, Chinese copies that are like $60. I'm sure you get what you pay for on that. So, Albrecht, I'm sure they're one of the best, and I'm sure you pay for it. But anyway, pretty pricey. I got another comment here from Peter Lucigian, 7295. It says, great insight on a subject that is new to me. I never would have thought the machine tools might be inaccurate. Oh, yeah. The cheaper you go down that Chinese price scale, the more you're going to find poor quality materials, excessive runout, poor dimensional accuracy, you name it. It's usually worth spending the extra money. And although I kind of operate on a budget, I do try to cheap out, but I learned a long time ago, you want to go with as much quality as you could possibly afford. And like I say, this is an eBay find. I don't know where this came from. I'm sure these are both very old, and I'm sure they're very well used. Anyway, who would have thought machine tools might be inaccurate? I now question everything, as you should. If you're making anything where a high degree of precision is required, check everything because error creeps in all over the place. There's very few things that you could do by accident that will make something more accurate. However, everything you do, whether accident or intentional, will make something less accurate. Question everything. Trust nothing when you're doing a setup or when you're buying parts or whatever, because areas you wouldn't think will be way out of whack. Who knew drilling a hole could be so intricate? And believe me, brother, I didn't touch on but the tip of the surface. When it comes to precision holes, there's degrees of accuracy that are unfathomable to me, I'm sure. And roundness. You bet you when you pick up that Makita or your DeWalt and you stick a quarter-inch drill in it and you punch a hole in a wall, that's nothing like the kind of precision that a guy often requires when you're doing, machining on crankcases, et cetera, et cetera. And, your typical twist drill, those holes ain't round and they ain't straight. They don't go in straight. The hole isn't straight and it isn't round. So, yeah, there are holes and there are holes. Anyway, moving on. Kopo Kitapu, I guess, says Machinery's Handbook recommends a run out 100 times smaller than the smallest tool you plan to use. So if I was going to drill an 1/8-inch hole, 0.125 into something, I should have a drill whose run out is 0.0015. That's getting pretty tight. Yeah, this wouldn't make it. But it's as close as I could get anyway. For most of the holes I drill are not that small, so this one would cut it. But anyway, Machinery's Handbook. I do have a copy of the Machinery's Handbook. I do consult it from time to time. I didn't look this up because I am too lazy. I'm sure if he quotes it, it's probably in there. I got another commenter here. Britain Roadhouse says if going for extreme accuracy, use a new US-made stub drill and a new high-quality collet. I often drill from collets, although not to improve accuracy. My problem gets to be that when I chuck up a chuck in the mill, you lose what is that, 2.5, 3 inches, 3 inches or 4 inches of headspace. And if I'm working on something tall, there ain't room for a chuck. So a lot of times I'll put a collet in there and drill from the collet for a different reason. But yes, I think he's absolutely right. A collet will be probably your most accurate way to do it. One of the problems I run into when trying to drill from a collet is that I have collets in 1/16 of an inch, which is great. But if you want to drill a hole that's 11/32, I don't have a collet that'll fit that. However, most drill bits, I'm not going to say all because there's always exceptions to all. Most drill bits, this area of the shank is machinable. And what I do in those instances, I will take my 11/32 drill, put it in the lathe, and turn the shank down to 5/16, and then it will fit in a collet, or at least one of the collets I have. If you're one of those guys that has collets in 30 and 64, it's not a problem for you. But yeah, in case you didn't know, most drills, this area of the shank can be machined down, and it comes in very handy if you... this one's getting kind of dicked up. I could throw this in the lathe and make this, smooth this up again and return it to a standard size like 3/8 or 7/16 or whatever so that I could fit it in a collet if need be. I got another comment here from a retired tool and die maker, Larry Sisk, 6562. And he says, first, 2 thou on a rotating shaft is 1,000 off centerline. You really can't expect better than that from a chuck. So Larry would say, yeah, this one's good because this one can do 2,000s. If I've got a precision ground tool in it, it'll be 2,000s. So yeah, that's good. That's good to know. I'm glad he pointed that out. And he goes on to say someone may have over-tightened something on the end of the Jacobs chuck jaws at some point in its history without full engagement of the entire jaw length, warping the jaw ends. Or they may have jammed a drill bit in there and spun the jaws on the drill shank, resulting in the jaws abrading and now essentially wobbling. And that's why they sell service kits. If your jaws get jacked up from spinning around the drill bit, like some Chuck has done on this drill, that's what the service kit is for. You can replace the jaws, although, as I stated, the service kits can be expensive. So the service kits ain't cheap if you buy genuine Jacobs parts, okay? And the reason I mention that is I saw this service kit, which Jacob sells for $220 or thereabouts, for $27 on eBay. How could that be real? It just, it was in a Jacobs box, but, these days that really doesn't prove anything. He's got a couple other comments about wobbling and jaw wear issue. And he also says here, lastly, when I chucked up the M-mill, its larger diameter put the jaws further up in the body, giving you better support on the jaws ends. And that's something I want to talk about right now. Better support than on the end of the jaws. I watch a machining channel, a guy named Joe Pye, professional, high quality, very high quality stuff. And he pointed out a problem on a 3-jaw chuck. If you've got, and this is my, non-computer designed drawing here, okay? You won't see any of that on this channel. I used a ruler on this one, so this is a high quality drawing. But anyway, if you've got a 3-jaw chuck, and here's my poor example of it, and you have a workpiece that you chuck up in the end, and then you tighten the jaws down. As you tighten the jaws down, the jaws are going to want to kind of rotate a little bit. There's a little clearance on all these parts. There has to be, or they won't work. And that little bit of clearance will allow these jaws to somewhat rotate. I'm sure probably not even a 10,000th of an inch. But when they rotate, the effect is that you're grabbing your workpiece down here on the end, on this corner. And really, it's now supported not along the length of the jaws and the chuck at all, but rather right on the end. So, of course, this is going to wobble. It almost has to wobble. Well, when you move over to your drill chuck, the same thing happens. And we've all done this because I drill a lot of holes where clearance is an issue, and I need a long drill bit, and I don't have a long drill bit, so I'll put the drill bit in at the very end. Well, when you tighten the jaws up in the chuck, you're tightening up here near the top. It wants to rotate the jaws around in this direction. So once again, you're putting all the pressure right on these corners because, they're not gripping the workpiece parallel anymore. They're gripping the workpiece at an angle like this. No, at an angle the other way, an angle like this. And you're tightening it down really on the back end, the back corners of your tool. So, yes, you want your tool, or in the case of your lathe, your workpiece, you want the jaws to go in, you want your workpiece or your tool to go in as far as you possibly can, because that minimizes the effect of the jaws torquing the wrong direction on you when you tighten them up. So, Larry pointed that out. He would be, I think, in agreement with Joe Pye's video. And don't ask me, it was a long time ago, what the video number was. I don't know, maybe you can find it if you search it. Anyway, looking for accuracy you desire, uses precision small chuck with a straight shank and a collet in the quill. Hope this helps. Thanks for the video. And last piece of advice, collet your center drill for the most accuracy. I think he's absolutely right about that. And I've had thoughts along the lines of his thoughts here, and I'm glad to hear that he kind of validated my thinking. But anyway, just a little follow-up on chucks. So anyway, we'll move on to the subject of today's video, cracks. Maybe that'll be the title, Chucks and Cracks. Anyway, moving on. Yeah. What you're looking at here is the primary side of some 1974 crankcases. And the thing that's especially sad about this is all of this damage was incurred as a result of crappy maintenance. Over the years, guys kept packing gasket sealer down into these screw holes, and the tighter you tighten the screws, that eventually, that gasket sealer can't go anywhere, and it bursts out. It's like the alien squirting out of out of John Hurt's chest. There, it's got to go somewhere. So it'll find a weakest point, and it will blow the hole out. And yeah, it gets nasty. And this is all self-induced. I'm not saying the current owner did it, but over the years, repeated poor maintenance practices contributed to doing this, and it did a lot of destruction here. So anyway, I'm showing you these cracks. I'm going to show you an interim repair step, and the owner. In the course of discussing this, he says, "Well, is it worth it?" I says, "It's never worth it. On the whole bike, you're never going to get out of it what you put into it. Is it worth it? Well, that's up to you. I could pack it all up and send it back to you. But anyway, you guys, what do you think you would pay for this? How many hours do you think it took to fix this? And what's it worth to you? I know what I ended up charging a guy. I know how many hours I put into it. And, maybe I'll tell you after I get some commentary from you guys. I'll do a follow up on this one and let you know what it came in at. But I want to know, what do you think? And just so you know what I'm talking about, every one of these cracks had to be ground out to the bottom of the crack. You can't weld over a crack. The crack is full of crud, oil, dirt, gasket material, bead blast, sand. Anything could be in there, and you can't weld over that shit. It will bubble up through the weld and destroy the weld. You have to grind it all out. Every crack has got to be open all the way to the bottom if there's any chance of getting a good weld on it. So on these cases, ground all the damage out of there, took it over to the bead blaster, glass beaded it, got that cleaned out, took it over to the power washer, power washed it. Then I soak it. I got a tub. I soak them in with water and degreaser to degrease it some more. And, rinse all of that out of there. Then I wash it again in just soap and water, actually Dawn dish detergent, and rinse it all out real good with clear water. And then I treat it with a little bit of aluminum brightener. And finally, they're clean enough to weld on. All right, so here are the damages all cleaned up. This one in the front was especially bad. The screw hole was split on both the inside and the outside, all the way from the top to the bottom. And then when it got to the bottom, it spread out across the crankcase like a T. And the crack went all the way through from the inside to the outside of the crankcase. This one was especially problematic because my torch head won't quite fit in between the Timken bearing boss and the front of the primary. So I ground this one all the way down to the bottom of the crack from the outside with the intention of, fusing the inside part of the crack from the outside of the case. So this one was a problem, yes. So here you could see the extent of that damage on the inside of the case. So here's one on the bottom of the primary. The screw boss was pretty much gone by the time I got to it. It had been replaced with a mountain of JB Weld. Just, for your own knowledge, JB Weld never, ever, ever fixes these things. You're wasting your time. Don't bother. JB Weld is no good. And of course, the problem with one like this is I've lost the hole. So I've got to build it up with a lot of weld because I don't know precisely where the hole is going to end up. So yeah, this one was a problem too. Here's the that little number 10 screw on the bottom of the primary. Once again, the boss was gone. A little mountain of JB Weld. And once again, JB Weld never, ever, ever fixes these things. Don't waste your time. If anything, they make them harder to permanently repair because you got to grind all the JB Weld out first. And as you can see on this one, the metal was so thin and so riddled with cracks that when I started grinding down to get to the bottom of it, it just disintegrated. This kind of a thing is hard to work with, but I did get it eventually. And here's where that small screw goes again from the outside, looking up at it. Harley, what were they thinking? Why is the case so thin right here? Jeez Louise. I assume it's because they wanted it to clear the kickstand. But you know what? Make the kickstand clear the crankcase. Don't make the crankcase clear the kickstand. There's not a lot of metal here to work with to begin with. Here's one up on top of the case just forward of the starter hump. Typically, this is more what that damage looks like. This one was easy to fix. If you're going to screw it up like this. This is easy to fix. Okay, and here's another one on the this one's on the top of the case where the screw hole was lost completely. Mountain of JB Weld. No, the JB Weld didn't fix anything. And I don't know if you'll be able to see it on the video or not, but these were stills that I took to send to the owner. And that area is riddled with little black dots. What happens is when I glass bead them, the glass bead dust gets drawn to any remnants of oil. So there's a bunch of little black dots in here, which are pores in the aluminum that have soaked up oil. And the glass bead dust is attracted to the oil and it gets stuck in there and it makes them visible where they normally wouldn't be visible. So this is one of the reasons welding Harley cases is a pain in the nuts, because it's very porous. All these pores trap oil, and when the welding torch hits one of those little black spots, it will explode in a gob of soot. And here's another one. This is another one that turned out to be pretty easy. It was on, I think, on the top of the motor. No, wait. This is on the bottom of the motor. A fairly easy one. But I'm looking for your guys' opinion. How much would it have been worth to you? And conversely, tell me how many hours you think I had into this thing getting it straightened out. And remember, every one of these that's welded has to get re-drilled. I put a Healy coil in them because the welding rod is a little softer than the parent metal. So I think a Healy coil gives it the better chance for long-range success. So every one of these has got to be drilled. Every one of them's got to be Healy coiled. Every one of these has got to be smoothed off with a file. Then the whole case gets laid on a surface plate and lapped flat so that you got a decent chance of getting a good mating surface. Okay, and here's another one. This one was, like I say, this is more typical of what I find, and these are a little easier when at least some remnant of the screw hole is left. But let me know your thoughts. And let me throw in here this too, not pictured. Not pictured. There were some areas on this mating surface where people had been filing it down, trying to smooth it up. Well, you can't file it down. If you file it down, you create a low spot, and the low spot will be a leak. So there were a couple of areas where I had to edge weld the mating surface, file it flat, and then lap it when I lapped everything down, flat all at one time. So let me think. Let me have your thoughts. Let me know what you guys think. How long do you think this took? And how much would it be worth to you? Is this worth saving or not? Well, I'm wrapping up this video that really ain't much of a video. This project is done for this owner. Considering the damage it came in with, it's really in pretty decent shape now. The welds are kind of lumpy. He wanted me to do this as cheaply as possible. And crankcase repair isn't cheap. Those are two words that usually don't go together. But anyway, the welds are kind of lumpy. I could have dressed them all off. But then again, if the owner doesn't like them, he could dress them off. Most of it is on the inside, the lumps and the bulges. As a guy who does the welding, yeah, they're a little lumpy, but what you're looking for is as you're welding it, you want nice shiny puddles. You want the beads to flow together, and these flowed real nice. And if you look at all the spots that have been repaired, which is almost all of the screw holes, you'll notice that you can't see where the crankcase ends and the weld begins. So yeah, they flow real nice. And you know, time-wise, when you're doing something like this, every one of these had to be filed off. Every one of them had to be re-drilled. The screw locations were lost because the damage was so bad. So the only way to locate the screws was to put the primary on it and use it as a template. There were only there were two screws that were unmolested to line up the primary with. And even with the two screws in it, the primary wants to wiggle around on you. So, you know, finding a screw hole locations is not as easy as one might think. But anyway, you put the two screws in, you drill one somewhere else, and you screw it down, take the primary back off, put it on, drill it, and you do that. I did it for just about every one to eliminate any chance of the cover shifting and causing a problem. There was a couple of spots, one up here where there was a divot in the cover, so I welded it on edge and filed it off flat. And then down in this area where the bottom was busted out, you know, people have been working this with the file and JB Weld and everything else, so there was a valley. Well, maybe not a valley, not kind of a valley, but there was a low spot. Let's call it just a low spot right in through here. Once again, had a weld on the edges, file it all flat, put it on my big surface plate, and you know, flattened it all off. So it was kind of a pain in the gonads. One other area worth noting: this front part of the case, where the screw had split and the crack had propagated, you know, along the primary inner wall. You notice this part here is dressed out, and the reason for that is this. When I welded it from the outside, I got a lot of penetration through to the inside, and there was a gob of weld here hanging off. Well, I wasn't sure whether there was actual fusion on the inside between the weld and the crankcase. So I got in here with the carbide burr, and I cleaned off the gob. And yeah, there was good fusion in there. So I welded the inside actually from the outside. And I could have dressed all of the case out like this. But once again, this owner, you know, said, hey, save me a few bucks. Well, okay. We'll save you a few bucks and we'll not dress the rest of the welds out. So anyway, I did get fusion from the outside to the inside. On this side, I didn't get quite as much penetration, and I was able to get my welder in here, my torch head in here, and got a little bit of weld on this side of this crack. There probably still is a little crack at the base of this, but I just can't get in there. But anyway, I got very good penetration from the outside, so, you know, the crack is contained by the welding on the outside of the case. So I'm all in all pretty happy with that. So anyway, yeah, I'm out of here. This will get shipped out maybe today, and we'll move on to whatever the next project ends up being.
Men, if you like this channel and this content, the single most important thing you could do to help grow this channel is to hit the subscribe button. I also have new design coffee cups and stickers available. You know, I like the old coffee cups, but I like these new ones even more. Links are included in the description down below. And for those of you who really want to go the extra mile, you could join me on Patreon. Link is also included in the description down below. And to all of you who have watched these videos, I'd like to say thank you. Thank you. Thank you very much. I really, really do appreciate it. We'll see you next time. Bye. And now, 2 words from our sponsor.
Super clean.
Ooh, nice.